I'm Max Egan. I'm a mechanical engineer and MBA graduate from the University of Alabama.
And I'm Travis Egan. I've been part of the manufacturing sector for the past 25 years. My son and I have traveled across the country to see the amazing advancements in renewable energy within manufacturing.
For our final season, we decided to explore the world of autonomous vehicles, the batteries that power them, and the people and places responsible for its future. This is Manufacturing Explorers.
All right, Dad, so we have officially made it coast to coast. Last episode here of Manufacturing Explorers Season 3.
Yeah, and this is a unique company. It's really got sort of this transformative feel. It's a new technology, and it all fits really well with sort of this journey that we've been on through the EV market, supply chain, sustainability, and this company represents all of those things. This river represents those things as well. Yeah. This river is an early example of supply chain. You know, they would float the lumber down the river, and this was a big shipbuilding area. So this was a huge manufacturing area. They would be building clipper ships here. In fact, Newburyport, where we are, is also known as the birthplace for the U.S. Coast Guard. So it's a pretty storied area, pretty storied town, and I look forward to taking everything in.
Today, we are just outside of Boston, headed to 6K Energy. After we've seen the batteries from inside the Tesla, and even back in Season 2, getting to see the massive battery storage facility at Moss Landing, we would finally get to take a peek inside the batteries. With 6K Energy being on the leading edge of manufacturing almost any lithium-ion battery material with their UniMelt technology, the only microwave plasma system capable of delivering a near infinite range of performance materials. This should be a fascinating look at a manufacturing process that is not seen in many places in the United States. But starting here at 6K Energy, that all might be changing.
Hello, welcome to 6K. I'm Mary Cronin. I run our government affairs program here.
And I'm Rob Davis. I'm the Chief Operating Officer at 6K Energy. So welcome to the Battery Center of Excellence. Here we work on both product development as well as process development. And we're going to show you a couple of full-scale UniMelts today so that you can actually see the plasma producing cathode active material ready for battery production.
So microwave plasma process, this is like a one-of-a-kind, first time seeing this technology here in the US?
New to the world, new to the US, and this will be the first time it's used anywhere in the world.
So here we are. Let me introduce you to Wyatt Olson, Program Manager for Product Development.
Good to meet you, Wyatt. Nice to meet you. Okay, Wyatt, this is interesting. What exactly is microwave plasma reactor, and how does it work?
Yeah, here, let me hand you guys these.
Oh, we better. Are we in any danger?
No, no danger. What you're looking at here, so this is a display of our microwave plasma that you'll see in the UniMelts out back. What we're doing is we're bringing a high intensity microwave energy into this zone up here. Okay. We inject gases into that area. Those gases get excited by that microwave. So we bring in a lot of energy, and that starts a chain reaction of ionization of those gases. So by all these electrons bouncing around, creating this intense high energy, we get this fourth state of matter you see here.
This is really interesting. We're really looking forward to understanding more about the process, the transformative technologies that you guys have in place here. So we're excited to go take a tour.
Yeah, let's go see where we make battery materials in the back.
Oh, wow. You can feel the heat. Oh yeah. Right?
The heat you're feeling, that's our 6,000 degree plasma up at the top here, and this UniMelt.
All right, so I have a question. So there's like 4 states of matter, right? Yeah. So we got liquid, gas, solid, plasma, and plasma is what makes up the stars and the sun. What are we doing here? I mean, this is foreign to me.
Yeah, for sure. So what we're doing here is we're actually creating an excited state of gas. So you can think about it this way. We have, when you boil water, you create gas. If you apply a lot of energy into a gas, you create a plasma. Those atoms, each atom is 6,000 degrees because it's such an excited state of matter. As long as we keep applying energy, that plasma is self-sustaining.
So hence the name 6K.
Exactly, yeah. Yeah, so we create a 6,000 degree plasma in our torch up here. We inject our ingredients, whatever material we're working to produce. We inject them through the top into that extremely high temperature zone, and we control the density of that plasma depending on what type of reactivity we're looking to get out of the material that we're injecting.
How quickly can you convert materials in a process like this?
Yeah, so the conversion in this is about 2 seconds. Many materials can be converted immediately that quickly. Some materials require a very short post-heat treatment to grow crystals in the case of single crystals, but the reaction that's happening in the UniMelt is 2 seconds or less. So in the traditional process, you have to do a co-precipitation step, which can take hours or days to get all of the salts to intermix nicely in order to create your battery cathode material. This is essentially replacing hours or days of operation with a few seconds of high-intensity plasma.
It was pretty amazing how quick this manufacturing process was compared to that of the traditional process. Before we headed downstairs, we wanted to take a look at the giant microwaves they had in the back that were integral to this process.
So what we have here, this is a microwave generator. So this is a much, much larger version of what you have in your kitchen. Yeah. These are actually off-the-shelf microwave generators used for defense applications, for food applications that are on the market today. So we're not using any specialty designed equipment to generate the microwaves to activate the gases for the plasma. Okay. As you can see, this is where your microwaves are generated. This box here, this is what we call our wave guide. And so we tune our microwave, and this is tuning it to get to exactly the right amount of forward and reflected energy, so that in our torch, we create a standing wave of microwaves, so the highest energy zone, and that's what we inject our gas through. Okay. And as we push that gas through, that's what creates that chain reaction to generate your plasma. And so even though obviously this is a very large microwave, it's coupled very efficiently with the reaction that's occurring in there, and there's very little waste.
Well, let's go down and see where all the final material kind of comes out.
Yeah, for sure.
Oh, it's much cooler. Heat rises. All right, so what do we have here?
Yeah. So this is our collection portion of the UniMelt. So this is where, as we talked about before, there's a very short 2-second reaction that's happening up above. All our powder is falling out, and this is where we would collect the powder and convey it to next steps in the facility.
So what kinds of end uses, in addition to batteries, are you guys making materials for?
Yeah, so at our facility here at the BCE, we're primarily focused on battery materials. We have a second division that's called 6K Additive. It's actually using the same torch system, a very similar UniMelt design, to make metals for the additive industry, so spherical metals from recycled feedstocks.
So when we got here, Rob said that this facility was more of a prototyping for the product and process. So this is this is a prototype essentially, and you've got a few of them here. Yeah. But you're going to then take this into production. I mean, that's the next step. Like, I think there's supposed to be like 15,000 EVs by 2025. So there'll be a lot of demand for this type of equipment coming in the future. So what are next steps on that? Where are you guys headed from a production standpoint?
Yeah, so this system you see here is actually a production prototype. And what you'll see is we have space for 10 UniMelts in this building. And these are, operating at essentially full scale. And that's one of the unique things. We're doing development on our plasma process at high throughputs, at full scale, because we can show that this is immediately scalable. Sure. So obviously in production, we have our production facility in Tennessee, which you'll talk more about with Rob. But in a production system, you could have multiple UniMelts feeding into all your post-processing steps. So you can imagine having many of these lined up and be operating it, so it's a very scalable process.
So I'm specifically interested in the battery storage applications of this process. Yeah. I'm curious to see if we can get our hands on anything or learn specifically about the batteries themselves.
Yeah, let's show you where we analyze our powder in this facility. We build our own cells for testing. We analyze our own powder. So let's get you in there building some cells.
Fantastic.
From here, I would go on to meet Dan, one of 6K Energy's senior cell engineers. He brought me through the entire process of testing the materials created in the UniMelt, from start to finish. First, they test the materials by putting them into a coin cell, which, if it looks familiar, that's because this version is fairly similar to what you would consider a watch battery. These are easy to build, require little material, and allow them to test the energy capacities of the materials they manufacture in the UniMelt. After the coin cell is prepared, they move them onto the cycler, which charges and discharges the cells. These go through a testing process that lasts close to 24 hours, after which point you can analyze the data to see how the materials performed. It was absolutely incredible to get to build and test the materials we had been seeing in their final form in our other episodes. Before this episode was over though, the 6K team wanted to show us their future plans for this technology.
Okay, so this is really fascinating technology. I mean, it's been really interesting to see the process part of this. So to meet the demand in the future, in the next couple of years, the ongoing growth of EV battery needs, what is your plan to build for production?
So we've committed to building our first full-scale facility in Jackson, Tennessee. We're going to build a facility of about 160,000 square feet. It'll produce about 12.5 kilotons, 12,500 tons of cathode material. That's about enough for about 100,000 cars.
We were fortunate in that we had planned to build our first plant, and it actually correlated at the same time with the bipartisan infrastructure law funding through Congress. So this was the first time that Congress had funded some sort of full-scale development for supporting the supply chain for electric vehicles since 2009. And so we were able to receive a large incentive package from the state of Tennessee to help support our workforce, which is critical. And the community has been incredibly supportive of our efforts. That was another one of the reasons why we chose that particular site.
We've targeted about 40% of our workforce either come from a disadvantaged community, a veteran community, a disabled background, or a diverse background. And so we've worked really hard to build relations with the team in Jackson, and they've been immensely welcoming of us coming into their community.
Mary, Rob, thank you so much. This has been a pleasure for us. We really are excited to see this growing new technology. 6K Energy with the batteries. Near and dear to my heart is the 6K additive coming from the manufacturing technology space. And then really excited to see what's next with 6K Next and some perhaps new materials, new markets, new opportunities to scale and grow this business in the future. I'm really excited to share this with my son and to make you guys a part of the Manufacturing Explorers family.